So let's begin. So I hope I'm audible to everyone. So let me share my screen first. So good evening to all of you. So my name is Dr. Pratyush Kumar, and I'm currently going to join just ETH Zurich as a SNSF fellowship for the postdoctoral. So I am going to act as a overall coordinator of this complete global workshop, which is going to happen from this July to I think it will be go around September last week. So I'm going to be the overall coordinator, and there will be other mentors who are experts in their own areas, own field. So they are going to. I'm audible to everyone correctly. Abhishek, please confirm that I'm audible.
Yes, yes, you are audible. Pratyush, you are audible.
Yes, yes.
So I'm going to. So other parts, other mentors are there. They will going to teach you their own area, their own field. So let me give you the overall outline which I'm going to present. Me and my these colleagues are going to present today. So this is the outline. So first we will start with our introductions. So this is since this is our first session. So maybe first our mentors will introduce themselves, and then you guys also can open your camera if you don't have any privacy issue, and you introduce about yourself, what project currently you are working, and what is your expectation from this complete session. So these things you can tell from your side. So this way we will be more comfortable with each other, because it is going to be, I think, around 2 months session. So it is required that we will be comfortable with each other. So there will be no hesitations among the mentors and among the participants. So that is why we should introduce ourselves. And second, we are going to tell you about some installation instructions. And here we are just going to tell you the instructions. And if you are still facing some issue, we will have a, so today is our first session, that is the 15, and which is not on a weekend. So we will have around 3 days. So 16, 17, and today's itself is 15. So around 3 days we will have, we will work out with you to help you out to install every required software for this session. So we will just give you instruction in today's session, but apart from this session, we are going to work with you in your free time, or in my free time, or in my members' free times. And before 18th, everyone should have complete all the installations and all the requirements for this session. Okay. So this way we are going to work on the installation part. And then we are going to today present about the module 1, module 2, and module 3, and module 4. So what are the things we are going to cover? and some of the ideas, so some of the instructions about the what is this course and what is means basics behind the, like in my module 4 where I'm going to teach you about that what is the pins, what is the how it is different from the physics informed machine learning, and what are the means advantage of pins over the CFD. These things we are going to must just we want to give you some means brief about the every modules in this session, and that way we are going to finish our today's session. Okay, and from the 18th we are going to start our first hands-on workshop. Once we all on the same page related to installation and the system, then we will start our first session from the 18th of this week. Okay, so for the instructions, let me start with myself. So I am Pratyush Kumar. So I recently finished my postdoc from the IIT Bombay itself, and earlier I have completed my PhD from IIT Bombay. So my project of research work was related to the porous media earlier in the PhD, and also I have worked with the CFDDM, that is the discrete element method, and my completely work was related to open source software. So for CFD part, I have used OpenFOAM. For means post processing part, mostly I use the Paraview either or Python script. So I know how to do the automatization in the Paraview. If you want to do the post process, suppose you have a, so because this machine learning and prints generally require the large data set. So if you are going to work for the data set one by one, so it will take you longer time. So in that scenario, it is requirement that you should write the automatized script so that means repetitive task will be performed by the your script. So these things I have done in my PhD during my PhD work, and I have developed around three solvers during my PhD, and one boundary condition and one means library. So in my condition, there is a requirement of to develop a source term into the means Navier-Stokes equation. So for that purpose, I have also developed a library. I've also worked for the multi-region solver. So means in OpenFOAM, it is very means hectic to develop a solver in multi-region. So I have also worked and developed a solver in the multi-region. So this was all from my PhD, and recently I finished 1 year postdoc in IIT Bombay. So where I have worked on the multi-phase problem. So I work on a development of a kind of a solver which where interfoam is integrated with the evaporation. So this kind of solver I have developed, and I have recently submitted one paper related to the my postdoc work. And means lastly, I have selected as a uh, uh, as an SF fellowship in the ETH jury, where I'm going to work on this multi-phase problem with the pins. So these things are this is my expertise and my means research areas. So I'm going to teach you about the module 4, which is the physics informed neural network. And once this all the three modules will be finished, then I'm going to give you some brief idea about what is the physics informed machine learning and what we are going to do in this module 4. So this is all related to my introductions. Maybe I can give you now, Abhishek, you can introduce yourself.
Yes, yes, Pratyush. Thank you very much.
So Abhishek, please,
Introduction.
while introducing yourself, please turn on your
Yeah,
video
yeah, I
also.
will, I will. Wait a second, I'm just sharing my screen. So I hope my PPT is visible to all of you.
Yeah, yeah.
So hello everyone, welcome
Abhishek,
to this
for now,
workshop.
just introduce yourself. Then later you can introduce about your module.
Yeah, yeah. So my name is Abhishek. As you can see here, I specialize in fluid structure interaction. You can see this video. So I have done my master's in which I have worked in porous media flows in SS and OpenFOAM in both softwares. Then during my PhD, I worked in flow-induced vibrations, in which we are focusing on energy harvesting, and it was the work was in the in-house code. We had to develop a 3D code also in that. So right now I'm a postdoctoral fellowship at Applied Mechanics and Biomedical Engineering Department, where my work is to like study bio-inspired insect flight dynamics. So in that we are focusing on how to introduce overset mesh method in OpenFOAM, as well as introducing the flexibility in different zones, and achieving a and also introducing a non-linear solid properties for bio-inspired insect flight dynamics. So basically, uh, insect has non-linear flexibilities in them. So we are trying to mimic that using the CFD. So in this course specifically, I'll be taking a fundamental of computational fluid dynamics sessions. So in this course, here right now I'll basically tell you a little bit about why CFD is important. Then in this course, first I'll take you to the fundamentals of CFD, then basics of OpenFOAM like folder structure, finite volume method, meshing, and boundary condition. And then we'll do a very simple problem in which we do a MATLAB code, and in the parallelly we'll uh, do in OpenFOAM, that is, we'll do the problem of heat conduction, like 2D heat conduction. So in that way, we'll relate the actual coding in MATLAB to the OpenFOAM, and then we'll run a simple simulation of lid-driven cavity simulation in OpenFOAM. So this is just basic of OpenFOAM and CFD fundamentals, which are very important. Later in the project part, we'll try to will project in reinforcement deep learning approach for active flow control. So the most important principle of CFD is garbage in, garbage out. So that's why knowing the fundamentals is essential. So you should know what you are giving in inside the code, what are the various processes it is doing, and why it is giving me value like this. So this is very important in CFD. So fundamentals are important. So why CFD? Because if you look in the nature, there are various non-linear dynamical systems which are not solvable using any analytical methods. So we need numerical methods for those cases. And experiments are costly, time consuming. So it is sometimes they are, to be quite frankly, impossible to do. So there is a need for virtual numerical experiments. So they have a lot of advantages, like we can do a lot of parametric studies. They are very cheap, and this actually reduces number of prototypes in physical trials. Easier visualization is there. You can look at the flow patterns and come up with the new models or new ideas of design. That is why CFD as design analysis tool is nowadays India is also catching up with India's industry is also catching with CFD, and it used in various industries such as aerospace, automotive, biomedical, and others also. So if we look at this simple flow in a channel, initially the initially the flow is developing. When the flow is fully developed, then you can see the the momentum equation comes out like this, where r is the radial direction. So you know for a constant dp by dx, this equation is very much solvable by and very simple analytical methods. So for this we don't need CFD basically. But and also if you look at 2D heat conduction problem, these three approaches are there through which we can calculate the solution for specific boundary conditions and shapes of the, like let's say a heated plate or some plate. But if you look at the governing equation for 2D fluid dynamics, they are not linear at all, and they are mutually coupled. So these three equations are mutually coupled if you have to transfer variable, as well as this x and y momentum are not linear. So for these cases, no analytical solution works. That's why I go into numerical methods. And on the top of that, sometimes you have energy equation as well. So we need numerical methods or CFD to solve complex dynamical system, be it fluid flow, structural dynamics, or there are various multi-physics simulation or system that are in nature. So fundamental of CFD first is in pre-processing meshing, then First, we'll show you the meshing, then we'll take you to the various discretization. So what discretization basically does is convert a PDE into a system of linear algebraic equation. That is, the PDE is converted into AX equal to that we have studied in our mathematics. And then it solves it. So we'll have a look in our sessions, or we'll try to understand how this process works, because it is very important if you want to go ahead in CFD and machine learning combined. And on the project part, as I have also introduced in the orientation, that my project will be focused on machine learning based active flow control. You can see a pitching an aerofoil which have a morphing part which is oscillating. So we can control this morphing part oscillation to achieve like drag reduction and lift enhancement, or more stability and maneuverability of any aircraft. And there has been a lot of work going in this field nowadays too. You can see on the left here, you can see on the left, one second, you can see on the left here that you can see on the left here that the flexibility of the tail of the aerofoil is controlled by some actuator mechanism. So this has been done nowadays a lot of time. So the point is to flow control the boundary layers development, flow separation control. That is active flow control we want to achieve. So these are the two models, two projects which has like both CFD and machine learning. The first is predicting flow field from cylinder. Pratish, please have a look at. So first is predicting flow field from cylinder wake using supervised deep learning. So this is a comparatively simpler project. The aim is to achieve this active drag reduction of a cylinder using a deep reinforcement learning. But this has to have, like, we have to have a lot of computation resource for these. So if there is, so we'll discuss later when we'll reach the project stage, when you have the idea of machine learning, we can discuss and we can choose any of the two projects. We'll try to do this. But if competition resource is not there with few of you guys, then we'll try to at least understand the physics of this, the methodology, and we'll execute this one, in which we'll simply predict the flow field of a flow over a cylinder. And if you have any other project ideas which are doable computationally, and you have resources, then we can also discuss those. And these are few books for basic CFD. You should go for this book. This I have read completely. If you want to do code development in C++, like advanced code development in CFD, you should read this book by Atul Sharma. He's professor at IIT Bombay. And for turbulence modeling, you can have a look at this. This is a Sal Rodriguez, Applied Computation Fluid Dynamics and Turbulence Modeling. It gives you very good perspective on what turbulence it is and how it is modeled. Like, it's nothing but gradients and assumptions. So you can have a look at these books before coming to workshop, because then you'll have a better idea of all the things. You'll grasp everything clearly and fast. Okay, this is all from my side. Thank you.
Yes, Abhishek, thank you for your presentation. One presentation is still left from your side. Maybe you can introduce about how to install using the virtual machine. Uh, you are hearing me, Abhishek? So maybe you can present that how to install using the virtual machine. So first, let me show you that how you can do the installation using the WSL. So I think most of you are using the Windows system. Okay. So for using OpenFOAM, it is necessary that Ubuntu environment is required if you want to use the OpenFOAM. Yes. So I think most of you are using the Windows system. So if you want to install,
Hello, Pratyush.
yes,
I
yes,
think we should provide them with the manual for installation if they have any problem, because during
yes, yes.
installation they'll do installation by their own pace. So let them
Check,
do the installation if they
I'm just
have
giving
any.
the brief. is also giving them brief.
Yeah, brief. Giving brief
Maybe
is okay. Yeah, fine.
later, if they will face the issue, we will going to install one by one to everyone.
Yeah, no
So
problem.
this is why we have 2 or 3 days gap. Okay, so if you means if you are using the Windows, so I think you need to first. I think you can see my screen. So this slide I share you in the group. So first you want to make sure that where your visualization is enabled or not. So for that purpose, you can just go to the task manager, and in the task manager, you can, if you see this performance panel, so you can go, we are going to see that it should be enabled. So maybe if I show my task manager, so you can see that my visualization is enabled. So that's why I am able to use the WSL. So if it is disabled, then neither you are not even able to use the WSL, or not even that means like Abhishek, the method suggested by Abhishek, you are not able to use that method also. So this you should make sure that you can uh, do this into the enabled mode, and for that purpose I have given this instruction. So just you need to do the power of your system, and after that you need to go to this BIOS, and this to go to the BIOS, different system has the different key. So sometimes it is either escape key or is this F2 key, and sometimes this is the delete key. So different system has the different BIOS key. So you can just search into the Google for your specific system, and you can enter to the BIOS. And after going to the BIOS, so you should navigate to the advanced tab, and after that you need to press the enter, and there you can see the option of the visualization and where you can enable it. So once you enabled it, so save the changes and reboot your computer. So once you are finished these things, again you should check that whether your visualization is correctly enabled or not. Once you finish this, just after that you can just go to the next step. Okay, so you need to this turn off or on your Windows feature if you want to use the WSL. Okay, if you want to know more about this turn off Windows features on IF, you can just go to this YouTube video. Maybe I can show you that what is this turn off. So you can just type in your search button, and you can click on this. Okay, so this kind of the Windows is going to open. Okay, here the things that you need to focus on, that you need to just click on this virtual machine platform, and these things, that Windows subsystem for the Linux, these two things you need to click, that virtual machine platform and this Windows subsystem for the Linux. And once you click this, then try to save it. So now you are at a position where you can proceed for the WSL installation. Okay, so just go to that how you can install the WSL installation. So okay, sometimes you can just go to this link where there are two method is given here. Either you can use the terminal command, or you can just follow the instruction. You are able to install the WSL. So when WSL is installed, you can download the 18.04, okay, or maybe at least latest version, or you can install the Ubuntu 20.04 or 22.04. Okay, so these instructions we are provided in many workshop or in many means other sessions. So earlier we were using the OpenFOAM 6 version. So for that version, Ubuntu 18.04 was compatible. But now in this session, we are going to use for the OpenFOAM 9. So I think here you can install at least 20.04. Okay. So greater than 20.04 is okay, but at least try to install the Ubuntu 20.04. from the MS store. Okay, so just to go to the here MS store, you can type MS store. Yes, here you can just look for the Ubuntu 20.04. If you type, it is going to show you the option. So here you can look for the Ubuntu option. It is going to show you. So different version you are going to find here. So maybe try to at least install this 20.04 LTS version or 22.04. Okay. So after once you finished this MS store installation, there after installation, if you are going to open that terminal Ubuntu 2.04, it is going to ask you username and password. Okay, and just try to enter some username and some part of password. Try to keep your username and password very means easy, because sometimes we found in our sessions that people give a very complex password and they forget that. So in that scenario, they have to again reinstall the Ubuntu and again install the OpenFOAM 9 version. So try to keep this username and password very easy, because already your system has a strong password. So don't require to give some complex password for this WSL system only. So maybe use some easy password here. Okay. Now for install, once you have installed this WSL and Ubuntu 20.04, then you can follow this instruction, this PDF. So how to install this OpenFOAM 9 version. Okay, so till here you have finished the part. So if you have completed this part, means you have completed this section. That is the second point. Okay, now you can follow the. So here there is a two option. Either you can install from the pre-built binary. Okay, so the only problem with this is that it is going to install the OpenFOAM 9 correctly, but it by default it install in some folder where you don't want to work in that folder. Okay, so generally this OpenFOAM 9 installs in the. So let me show you uh, what I want to say, because then you can correlate it easily. So due to this reason, so once you install the Ubuntu, you are going to see some terminal like this. Okay, and if you go here CD, and if you see the different structure in the your root directories, you are going to see this kind of the folder structure. And by default, if you want to install the OpenFOAM, so it's generally installed in this folder, that is the OPT folder. Okay, so when you want to transfer the file, some files in that OPT folder from the Windows, so it's very difficult to transfer that file into this OPT folder. Okay, because it is in the inside the root directory, and some system don't allow to work in the root directory. Okay, they only allow to work in your own home folder. So in that scenario, generally I don't advise to install from the pre-built binaries. Okay, in means, because we are going to learn more of the programming things and more of the development things. So that is why I write it here that it is for the advanced users. So generally, when people only attend our this basics classes, so we have, so if they are only attending the 2 days classes, so we just suggest that install this pre-built binaries kind of the folder and just work with that, because in those classes we don't introduce about the programming and development things. But since we are going to have 2 months classes, so I think you are going to understand about advanced development things. So I would suggest that try to install from the source. Okay, just try to follow the instruction after opening the terminal. So just copy the things here and paste here. Everything's just copy here and paste here. Okay, so this is the things you are going to find here. Okay, and this you need to add the base RC that once you correctly install the OpenFOAM and try to source it, and after that you need to install the third party also. Okay, and once you are completed the third party installation and as well as the OpenFOAM installation, you are going to see if you are going to put this simple form help, so it is going to show you some text. It is not going to show you error. So if I currently type simple form help, it will show me error that simple form is not installed here. Okay, but when I type OF90, so I'm creating the environment of the OpenFOAM 9, and when I type here simple form whole, so it is going to show me instructions related to the simple form. So now you can see that it is not throwing me an error. So when your OpenFOAM is correctly installed, and if you put this OF9 command, and after that if you put the simple form help, you should see such things. Okay, it means OpenFOAM is correctly installed. So this is something brief about the installing the OpenFOAM. So these things you are going to follow either if you are using the virtual machine or you are using the WSL installation guide. So these things is same for means any kind of system you are using, because this is installation for the OpenFOAM. Okay, for getting the Ubuntu kind of environment, you can either use the WSL or you can use the virtual machine that we have also shared one slide here. So virtual Ubuntu 20.0 virtual machine. So this instruction is just for that how you can use the virtual box for creating the Ubuntu kind of environment. After creating the Ubuntu 20.04, you have to follow this instruction only. Okay, so you can either use the WSL installation or you can either use this virtual box kind of the system. So that instruction is given in this folder. Okay, so try to create both are means if you're using the Windows system, both are is going to work in the similar way. Some things has advantage in the virtual box and some things has advantage in the WSL installation also. Okay, for example, for visualizing using the PyraView, so this virtual box is more compatible, but if you are using the WSL installation, we have to means use this PyraView as a third party software. We cannot directly use PyraView using the Ubuntu terminal, because Ubuntu in WSL treat PyraView as a someone is trying to connect.
Pratyush, who is this Amit
Yes.
Joshi?
He is uh,
Continue.
yes. See, Rahul, you can also use the ESI version, but since most of the people here is going to work with the .org version, so I think it will better for everyone to use OpenFOAM 9 kind of system. Okay, maybe if you have some specific project related to the OpenFOAM ESI, we can discuss in some of the classes. But I think for the present time, we need to just stick with the OpenFOAM 9 version. Yes, foundation version we are going to keep for this session. But if you have some specific project, then we are going to discuss that also. Okay, so don't worry about that. So this is all installation related to the OpenFOAM 9 as well as the Ubuntu. Okay, just try to follow the PDF, and if you are facing any issue, just let us know, and we will maybe fix some particular time for your installation, and any of our mentors will going to help you out before 18th of this month. Everyone should have the installation of the Ubuntu as well as the OpenFOAM 9. Okay, so this is related to the installation. Okay, maybe I can now invite some other mentors who can present their module. So maybe Suraj Prabhu, if you are here, you can present your installation as well as installation as well as introduce about yourself and Kundeswar Prabhu and your about your topics that you are going to teach. So Mike's over to you.
I'm audible, right?
Yes, you are audible.
I'll just try my screen. So, hi everyone. My name is Suraj Racha, and I'm a PhD student in IIT Bombay. I work uh, in a department called as Koita Center for Digital Health. It is basically my work involves using machine learning AI, specifically the large language models, in a healthcare setup. And I'm also a AI research assistant at BharatGen. So those who do not know,
Suraj
BharatGen is
Prabhu,
basically,
can you put into the presentation mode?
yeah, I have to share my whole screen. Just a second.
Yeah, full screen.
So, so again, my name is Suraj Racha. I'm a PhD student at IIT Bombay. In my PhD, it's in a department called as Koita Center for Digital Health. So it's completely based on machine learning, large language models, and we are applying in a healthcare setup. And I'm also an AI research assistant at BharatGen, AI researcher. So BharatGen is basically India's first generative AI ecosystem. So we have actually built LLM models for India. So it is like one of the first models which has come out of from our country, and like we take pride in saying that we are the pioneers for it. So I will be the mentor for machine learning, and similarly Kundeshwar Kundalik. He is also an MTech graduate from IIT Bombay, and he's senior AI engineer at Bharjan. We are working together, and we'll be happy to take this machine learning course ahead as module 2. So just an overview for our current today's setup. We'll have an introduction of machine learning, why we need it, and then we'll see what we'll be covering throughout the module. And also we'll go through the installation, which serves as the first basic step. And we'll also just look into brief of some how the machine learning environment looks like. So see, what does machine learning essentially mean? So I'm assuming that the crowd may be mixed. So some of us may be knowing machine learning in detail, some of us may not be knowing. So we'll start from the basics. So machine learning is basically, so here machine is basically the computers. So computers are technically machines. So machine learning is basically we are providing the ability for machines to learn. Just like we as humans, we learn from our childhood, we learn languages, we learn to perform tasks. Similarly, you can also train machines so that they are able to perform tasks. Now, how is training different from programming? So, uh, we may be aware of little bit of coding. So we can write a for loop or a if loop, if else condition. So if else condition is not really learning. It is just like some robot is acting based on certain conditions. Like if it is raining, then do not go outside. If it is not raining, then go outside. So this is not learning. This is following rules. But learning means actually giving the ability to predict. So some of the tasks, it can be like translation, question answering. We all use ChatGPT, question answering, labeling images, something very, very important in the healthcare domain. Then facial feature extraction, like we are having CCTV cameras, our phones use so much of it. And of course, CFD is one great part of it, uh, of the applications of machine learning. Now, how does the learning basically happen? Learning happens through something called as training data. So we are aware about this particular training, like we go to a gym or exercise, yoga. So this is training for the body. Similarly, there is the machines itself can be trained. That is possible. Now, how is that possible? That is possible using training data. So in a nutshell, training data is something from where the information is coming. I'll just give one example. If we want to learn CFD, now in the beginning, we do not know CFD. We are all beginners. But then we read some books, we attended classes, we spoke to professors, we saw some YouTube videos, and then after a point, after a few months, we got hold of CFD. So this attending of classes, reading of books, searching through the internet, these are the training data. These training data went into us if we are the model. This training data went into us, and the output is we are able to understand CFD better. Similarly, in machine learning, of course, in machine learning, it is much more mathematical, and we'll look at that. The training data is always in pairs. In pairs means there is some input and there is some output. And the machine learning happens through examples. So this is also very common, right? Because we as humans, we learn through examples. For example, we are learning, okay, this particular fruit is a mango fruit. It is an apple fruit. So how do we know? We know because we have seen a lot of examples. Of course, we know that mango is yellow or apple is red. But then seeing a lot of examples helps. Similarly, machine learning happens through examples. The main learning happens through examples. And while we are inferencing, like while actually using the model, we do not see the trained data. While using the model, the data that is seen is completely new. Now, in this module, we will be covering a lot of things. So first of all, setting up a Python, NumPy, the whole Python environment. Then in detail, we'll be looking into the basics of machine learning, the mathematics of it, especially regression and classification, then data pre-processing, overfitting, how do we actually train the models, and overfitting, train test curves. Now, there are a bunch of hands-on coding also, for example, visualization, because uh, the CFD itself will be using for maybe for a research or at our workplace presentation. Then presentation becomes a big key, even though you are having all the theoretical knowledge. But if you are not able to present well through graphs, you do not know what graphs exist or how to actually code them up. What are the techniques in graphs also? Then we may have a backdrop. But if we are able to present well, then it's very useful for our careers. So a complete hands-on on visualization of various plots. Then we'll have a linear regression on synthetic fluid data property. This is also a hands-on project. Then the next step is we'll go into more detailed algorithms such as decision tree and RF basics. These are more detailed algorithms. And RF is random forest. Then we'll also see an hands-on training for random forest for viscosity prediction, and then model evaluation and metrics. Because see, if you build a model, but then you do not know how to exactly report it. If I say that the viscosity of a fluid, uh, or very simple, uh, there is a container, then if someone is well aware about the domain, then they will say, okay, so in 5 liters container. But if I say, okay, there's a container and it is 10 kg, then I mean the metrics are mismatched. We do not know where to apply the right metrics. So how to evaluate the model and how to apply the metrics, then cross validation and hyperparameter tuning. And neural networks and transformers we have added. Will not go into much detail, but we all should know, because neural networks and transformers are like they become the heart and soul of advanced machine learning. So why is this added? Because if you get some idea about neural networks, transformers, LLMs, then in the future it is possible that you will be able to self-learn many more algorithms based on this. Now, coming to installation, we'll quickly set up the installation. We'll go through this. Uh, the installation guide is already shared with you. So what are the installations? First of all, VS Code we'll be using for at least for the machine learning module, we'll be using VS Code. Now, VS Code is where we code up. We code the things. Then Python is the coding language we are using. And then environment setting up, installing different packages in Python, and how to make scripts and run. Now, this is already shared with you, but we'll also look here. Yes. So number one is we are installing VS Code. So we go to the official VS Code website, and you can install for your So you can install for your own operating system. For example, in this particular PC, in this particular laptop, I'm using Windows, and in my work desktop, I use Linux. So if it is for Windows, then you can use Windows, or if it is for any other platform, you just click a other platform and you can install for Linux. Linux you can install .dv deb, and for Mac also similarly. So install the VS Code, and after installing, you will get the running execution function. When you run that execution function, I've already run it. So it's very simple. Like you just run those execution function, just like we install any other application. Then you can search VS Code, or you can also create a shortcut icon for it. So this is how the platform looks like. So now I've just opened one of my workspace here. This is how the whole platform will look like. Yes, here. Now the second step is we want to install Python. See, Visual Code is just the platform on which we are running, but the actual coding language is Python. So we want to install Python. So from here, this python.org is the official website for installing Python. I would recommend install the latest version, which is 3.13.5. Why? Because you can obviously install any previous version, but in machine learning the world is very fast moving, so they keep on updating, and if you install some previous version, then it's possible that some of the packages may not be supported. So just click here, Python. So just click on your OS. So I'm using, for example, if I want to install for Windows, I'll click here for Windows. Similarly for Linux and Mac, you can click here, and that will install your Python. That will at least download it, and then you similarly click click on the execution function and do the next command. Now you want to verify whether the Python is installed or not. This can be done through multiple ways. This can be done through the terminal or the VS Code also. I'll show you through the terminal. So if you are using Windows, then just type in CMD command prompt, or if you're using Linux, then Linux or Mac, type in terminal. So this will open a terminal. Now you want to see whether Python is installed. So what I'll do, Python -- version, and this is showing me Python 3.11.6 is installed. So this is slightly earlier version because uh, I I already had Python previously in my laptop. And similarly, see, if this command doesn't work, so in some of the devices, this will work mostly, but in some of the devices, Python is installed as Python 3, especially if the Linux is there. Python 3. This 3 is nothing but, here you see 3.11.6. This 3 is the 3 version. So if Python is not working, then just type Python 3. Python 3 version. For example, in my case, this will not work because in my device, it is recognized as Python. So in most of the devices, this should work, Python version. But just in case we have given in the installation also, this doesn't work, then type in Python 3. Now we want to install pip. So pip is again, you can say a platform from where all the packages can be installed. For example, you want to install NumPy or Matplotlib or Pandas, etc. So pip is a world where, like, a platform where all the packages are there. So if you want to verify, so most of the time pip may come with the Python itself. So before installing, just verify this. How will you verify? Just type, similarly to Python, just type in pip version. So in my case, you can see pip is installed, pip 23.2.1. But if you see that pip is not installed, it's very easy. You just go to PIP's website here, as I mentioned here. Just go to PIP's website, and if you are using Linux, just type in this particular command in uh, the terminal. Similarly, if you are using Mac OS, type in this command, and if you are using Windows, type in this particular command. So this will like install PIP. Sorry, I'm wrong. So this is for upgrading the PIP, but for installing the PIP, you want getpip.py. So this one, I'm again saying in most of the cases, PIP will come with your Python installation, but just in case if it has not come, what do you do? This is the official PIP website. I've opened to the uh, installation guide provided to you. You go here, getpip.py, and if you are using Linux, you type in this command. Similarly, if you are using Mac, you type in this particular command, and if you are using Windows, you type in this particular command. In the terminal, as I've shown, in the terminal here, this will install pip. Now, second is see, Python has been installed somewhere. VS Code has been installed somewhere. This is a very important step because many face problems here. But you want Python and VS Code to merge together. Like you want that both of them are used together. So what you do, you want to install the same Python in your VS Code also. So what you do, here there is extension here on the left side. Either you press Control Shift X, or you can directly see for extension tab here. And here, basically, all the extensions you can install from this particular place. So you just type Python, and install this particular one, Python extension. This Python. So I have already installed, but if you are not installed, you will be seeing an install option here. Just like I'm just opening something else. Here you see the install option. Similarly, for Python, you will be getting an install option here to install this. So now what has happened? VS Code has got the Python package in it, like the Python environment in it. Now the second step, what you want to do is the Python has installed somewhere in your device at some particular path, and VS Code is in some other folder, some other path. Now VS Code has understood, okay, it needs Python, the environment is set, but you have to link the Python path to the VS Code's Python. For that, what we'll do, just press Control Shift P. If you're using, of course, Mac, then you can press Command Shift P. So Control Shift P. This will open on the top. This will open some drop-down menu kind of thing. You can search. So there, you just type in Python, select interpreter. The option will also come. Now here, I am having a lot of, because I had upgraded my Python, then I had used some other Python versions also previously. But here you will be getting your Python, which you had installed. You'll be getting your Python there. You can directly click on this. For example, I want to set this as the default, Python 3.11.6, the original one. I'll click on this. So the Python link has been set. Now our VS Code is ready to be used. Now what we do is, see, before starting any code, first of all, you can select your folder. How do you select folder in VS Code? Is you click here, file, you open a folder. For example, I want to create a very fresh new something. So I'll say, okay, here, then I'm creating a new folder. So I've opened this folder now. Now whatever code or whatever scripts I write, everything will be saved here only. I hope you followed how to open the folder in VS Code. Now, second is we want to set an environment because a lot of packages will be installed. So the same Python, different people can also use. So we do not want that we delete someone else's environment or they delete our environment. So for that, Python packages, for that what we do, we create an environment in which all the packages will be stored. I think Pratyush has also spoken about this environment. So what we do, first of all, we open a terminal. So here you can open new terminal. So this is what the terminal looks like. And you see the terminal path is in the folder. So whatever you're coding will be there in the folder, the scripts which you make. Now we want to make a new environment. So what we do, Python, either Python 3 or Python dash m benv and the name of the environment. So Python dash m benv and the name of the environment. The name of the environment I can give anything. For example, to ML module or module is the name I give. So this creates a new environment with the name module. It will take some time to create. So now after creating, the next step is we want to verify whether the environment has been created and we also want to log in to that environment. So see, the code has run and it has created, but we do not know whether it has created or not. So what we do, if we want to activate it, there are two commands. For Windows, it will run differently. For Mac and Linux, it will run differently. You can follow the command here. So the name is module. A module slash script. See, I didn't type the full one also. I just pressed the tab because scripts command is already recognized. So I just press the tab command. Scripts tab activate and it will activate module. Here you can see module. So we have logged in into the environment. Now, of course, we want to again verify that the pip is there working in the environment also. Yes. Now, whatever packages we install, it will be there in this environment. For example, I want to install a package called as NumPy. There's a package called as NumPy. So how do we install this? Pip install the name of the package. So the name of the package is NumPy. And I just press OK. So it is looking into the pip website and it will install. It will take some time. So if you want to see what all packages are there, you can just type in pip list here. Sure. So it has successfully now installed NumPy. Now, if I want to say what all packages are there, and just type in pip list. So it has NumPy. It only has NumPy and the default one. So I have been using this VS Code for a long time, and in my other working environment, I have a lot of packages. But here it is showing only NumPy because I have logged in into this particular environment called as module. So in this particular environment, we are having only NumPy, which we had installed now. And similarly, you can create scripts. For example, I want to create a script. What I will do in this module, just see this new particular tab, new folder, and you type in something like with Python. .py. Just remember that each of your script names should be py, .py, because py is the extension of the Python file. Now, what I do, very simple. We are saying print learn ML. This is a very small command, print learn ML. Now, how I'll run this command, how I'll run this script is in the terminal. I'll do Python, and the path of the script. So we'll look at this more detail. We'll keep on doing, but there are many methods. One method is I just right click this, I copy the path, and I paste it here. It is knowing that it has to run this particular script. And say it has printed learn ML. It's a very simple script. Okay. Now we can move to the next parts of it. This covers most of the installation. And very basically, will not go into details, but in a very basic thing, I want to tell you that the fundamentals of machine learning, like supervised learning, unsupervised learning, classification, these become the foundations of understanding machine learning. Like supervised learning is something where data is present already. Unsupervised learning is something where the labels are not present. So you're just categorizing it. And then a simple example, like if you want to build a spam detector, whether the email that has come in is spam or not, then how do you make the data set? What is the output prediction? Then what is the input that goes in? How are you defining what is spam and what is not spam? All this will look. And some good references for machine learning are this particular book, Python Machine Learning by Sebastian. This is a very famous book. This is something you can use for your reference. And at the same time, the most handy thing for machine learning that will come in your hand is using Google, using ChatGPT, etc. also, because that's really handy. For that, of course, you can. Hugging Face is a very good platform to keep up with the pace, what is happening in the machine learning world, and blogs like Google Blogs. These are very good for keeping up with the pace, like what exactly is happening, any new technologies that has come up. And for any of your day-to-day challenges with machine learning, how to use some modules, etc., like doing a simple Google search will also work. And if you want to learn deep theory, this particular book can be used as reference. Thank you so much.
Okay, Suraj Prabhu, thank you very much. It was a very nice presentation, and many of the participants is personally messaging me that they are not able to catch up the speed for now, because currently we are not doing the hands-on workshop. We are just telling that how to install these things and what are the prerequisites for the session. So that's why you are not able to catch the speed for now. Once you have the everything installed in your system, then we are going to work one-to-one kind of hands-on practice will be there. So don't
Yes,
worry.
yes. So when we are doing machine learning, the actual session from next time, we'll go very slowly. We'll not assume that anyone knows anything.
Yes. So it's just we are giving good touch. That's why you are not able to catch for this time. So don't worry about it. Just I'm going. This session is going to record it. So once you are able to install virtual like VS Code and Python and the pip, so maybe you follow the instructions that has been given into the recorded session, and maybe if you are facing any issue, you can just share the screenshot or any message into the group. We are going to help you out. Okay, and if you want to means find out the recorded session, so this when I complete this session, after I think 2 or 3 hours, you are going to find the recorded session into the file folder. Okay, so maybe before going to the next mentor, maybe we will start into means asking introduction from our participant side. So first, Amit, you can start introducing yourself. So just try to give your name, what currently you are doing, and if any research work if you want to share, you can share. It's up to you whether you want to share or not. And last thing, that what is your expectation from this workshop? So these things, it's up to you whatever data you want to share. If some people face the means privacy issue, so it's up to you that what you want to share and what you don't want to share. So first, Amit Joshi, you can just turn on your video. Amit, are you there? Okay, I think he's not in the. So next, Amit, view okay?
Uh, Hi,
Yeah. So try to turn on your camera also.
I am Amit. I'm doing my PhD from IIT Bombay. Currently working on CFD with Anjishnu Chaudhary and Abhijit Kumar. I'm doing a German-based project that is on cerebrospinal fluid, and it's just starting phase of my PhD. Like it's 1 year. I have done 1 year of my PhD, and now like going to do some ML programming also in my project so that we can predict on how the CSF behave in our brain so that it will be helpful to the community so that we can find out how the Alzheimer's are acting and other diseases that are happening due to CSF. So basically I'm doing the basic dynamics on CSF, how the brain, so how the CSF is behaving inside the brain. That's all. My project is on that, and I want to learn this course. That's why, like, my project is like half CFD and later half ML will be there. So I want to incorporate both the things in my project. So that's why I'm doing this course.
Okay, Abhishek, thank you for introduction. Anuj, you can turn on your camera and mic. Amit, please turn off after speaking. Anuj, you can turn on your mic. I think he is also not. Hema Kumar, you can turn on your mic and video.
Hello, am I audible?
Yes, yes, you're audible.
Uh, Actually, I couldn't turn on my video. I don't have a webcam. So myself, Hema Kumar. Uh, I'm currently in my fourth year of bachelor's degree in mechanical engineering. I'm from Chennai, Rajalakshmi Engineering College. So I want to explore CFD field because it's interesting. Had done few projects based on CFD using ANSYS and even OpenFOAM, and I want to further develop my learning. That's why I joined the course. Happy to learn things from you. Thank you.
Okay, ma'am. Thank you for your introduction. Arvind Jaglinki, Arvind, you can turn on your mic. Arvind, are you speaking? Because we are not able to hear your voice. So I think your voice is not coming. Maybe you can type your introduction into the chat box. Yeah, Amit Joshi, now you can, I think you can introduce yourself. Your voice is not coming, Amit. Amitji, your voice is not coming. You are not able to hear. I think you have some network issue.
Hello, hello, hello. Am I audible now?
Yeah, you are
Yeah,
audible
yeah.
now.
Yeah, yeah. Okay, okay, okay. So, so my name is Mr. Amit. I am actually a PhD student in from BITS Pilani, and I am doing my basically my PhD is basically integrated along with my profession in engineering. So I am working. I am actually working as a you can say as a integrated program from my company with my company and this bits pilani. But actually I passed out mtech in from the same institute, and now I am working. I am taking taken this phd assignment, and my subject is basically computational fluid dynamics with FSI. So my problem is with respect to the actual problem or actual problem statement in the practice, that because of the various what you can say sources of the flow induced vibrations. Basically studying the different sources of the flow induced vibrations over the heat exchanger and the boilers basically, which I am practically facing this problem in my organizations there, and I'm working with the taking that as a problem statement. I am doing this research project there. So my research project is actually a combination of three stream, you can say. One is fluids, then structure, and then after that combustion technology, or you can say thermoacoustics. Thermoacoustic I can mention as a basically part of the flow induced vibration only, but the combustion engineering for the applicable to the boilers and boiler system. So these three stream are intersecting at one point, and whatever the dynamic forces are coming over the boiler system, that I am analyzing it and applying it to the structural design of the boilers basically there. So that how can I make the more robust structure, as well as how can I reduce or nullify the vibrations. This is the total problem statement which I have. Hope I am clear and loud and
Yes,
clear.
yes. Yeah. We are able to hear you. Amit, I think
Yeah, yeah. So what?
just in this session, we are going to cover content related to fluid mechanics and machine learning. So some of the topics will be covered definitely, but some of things like related to the structure, I think this course is it will give you some idea, but not particular to structure and other things.
Okay, so this
Yeah,
particularly course is devoted for the fluid dynamics. Am I right? This
fluid
one?
mechanics and machine learning and pins. Yeah, I think we have talked already on phone call.
Yeah. We talked on that one. Only,
Yes.
only I would like to just have the integration or integrate rather than integration. I can say the how to couple the this problem about the structure and this one. If you give me the guideline on that, that will be
Yes,
helpful for
we
me. I'm not
so, we have Abhishek Thakur, who is
I'm not
mastering
expecting.
FSI kind of problem.
Okay, okay.
We will definitely help you
Yeah,
out.
yeah.
Okay, so
I'm not expecting that structural dynamics will be taken in this course. I am basically
yes,
interested in coupling of the fluid dynamics with the structural problem. That one, FSI.
yes, Amitji, we can talk
Yeah, Amit. We'll
in
definitely
person.
help with you that.
We will talk in person.
Okay. Thank you.
Okay. Thank
Now,
you.
Jamshid, you can introduce yourself. Jamshid, you can introduce yourself if you are here. Anyway, next is the Jinu Chandran. Yes,
Am I
Jinu.
audible?
Yeah, you're audible.
I'm a PhD student from BITS Pilani. So I work on jet engines when we turn to problems. So I wanted to explore pins and machine learning and OpenFOAM. So these were driving me to join this class. So these are my expectations to learn out of it.
Okay, Jimmy. Thank you for
Thank you.
introduction. Yeah, so please keep your introduction shorter because many people are there. Kapil Kumar. Yes, Kapil.
Hope I'm audible.
Yes, you're audible.
Currently, I am in my final semester of my masters at IIT Mandi. I'm working on coal combustion and coal gasification. My particular focus is to learn the OpenFOAM because since I am using ANSYS Fluent for my simulation purpose, uh, I am facing a lot of problems in custom solver. Though in ANSYS Fluent provide user-defined customization, but we cannot modify the solver at the end, that is backend. So I want to learn OpenFOAM for development purpose in my future, since I am also targeting a PhD abroad. So and at the same time, since the trends are towards the accelerating the simulation through machine learning, so for that purpose I am interested in this course.
Yes, Kapil, definitely you are going to get benefit from it. And I think you are right about the OpenFOAM. If you want to do some development, so OpenFOAM is the better than some of the like commercial software.
Yes, sir. Because
And
ANSYS Student framework doesn't support custom
yes, yes, I
customization
know.
of the.
I have faced this issue. When I started my PhD, I was in the same situation in the porous media. That's why for the academic and research problem, I can definitely say that OpenFOAM is the best solution.
Yes, sir.
Yes. Saurabh?
Hello, am I visible and
Yes, yes,
audible?
you are visual and audible also.
Yeah, hello everyone. Myself Saurabh Kumar. I've completed my master's in mechanical engineering and currently I'm doing a job related to CFD. I am interested in like applying ML to optimizing like FSI based problems. So that is a topic that Abhishek sir also told that he's working on. So I'm interested in doing a PhD on that. Yeah.
Yes, Saurabh, and also I think he's going to discuss one project, maybe not because he says that computationally it's not possible to cover that topic in this session. Maybe he will just go through the every coding and everything. Maybe solution simulation is not possible, but he is going to definitely cover one project related to the FSI and ML. KV,
Yeah.
KV, heard me?
Yes, sir.
Yes.
Good evening, everyone. I'm Devi Harni. Hope I'm audible. I'm from Chennai and I'm currently an MS student at IIT Madras. I started working in this in-house software called IITM Runs TD. I'm from the Department of Ocean Engineering. So I also wanted